Hello everyone, I'm Chen. In this presentation, I'll talk about the SoundSpaces challenge we organized this year in collaboration with Una Jane and Kristen Grauman. Moving around in the real world is naturally a multisensory experience, and an intelligent agent should be able to see, hear, and move. And this motivated us to organize the first challenge on audiovisual embodied AI. More specifically, this year we targeted audiovisual navigation in 3D simulated environments. As the name suggests, this challenge is based on the SoundSpaces platform that we developed recently. And the prize for the winning team is AWS credits worth $5K US. Let's first get a taste of the simulation. SoundSpaces is a habitat-based audio simulator and enables audiovisual navigation for two visually realistic 3D environments, Replica and Matterport 3D. In this challenge, we only use a Matterport dataset due to its greater scale. For each environment, we discretize it into grids, and the room impulse response is computed for all pair of points on the grid, as shown in this figure. In the Audio Go navigation task, there is a sounding object randomly placed in an unmapped environment, and the agent receives 1 second audio clip emitted from the source at every time step. The agent is tasked to navigate to the sounding object in the environment with one of the 4 actions: move forward, turn left, turn right, and stop. And the success is defined as when the agent issues stop action at the source location. In this challenge, we consider the unheard sound setting, where the model is trained on multiple sounds and tested on unheard sounds. There are 73, 11, and 18 disjoint sounds in the training validation test sets. Note that the environments are also split into disjoint sets, so it requires the model to generalize to both the unseen environments and the unheard sounds. In addition, we created a new challenge test set where the sounds and episode configurations are different from the public test set, and the best performing team on this split was announced the winner. For each episode in training validation and test, we varied the scene, start location, start rotation, go location, and the source sound. After calling the stop action, the agent is evaluated using the success weighted by path length metric. In this year's challenge, we used the audiovisual waypoint navigation model from a recent paper as the baseline. This is a state-of-the-art model on audiovisual navigation, and the code was made public before the challenge. The key idea in AV1 is to learn to set audiovisual waypoints end-to-end at different granularities. In addition, this baseline builds an acoustic memory to help infer go locations and decide stop actions. This year, 7 teams from varying universities queried us about this challenge. 2 teams were able to make successful submissions on the test set. Among the 2 teams, Freiburg Sound outperformed the AV1 baseline by a large margin and wins the challenge. Congratulations! Team Freiburg Sound used data augmentation to improve generalization to unheard sounds. They also find that auxiliary loss on the spectrogram reconstruction improved the performance even further. Next, we'll discuss future directions for SoundSpaces challenge and transition to the presentation recorded by the winning team. This is the first SoundSpaces challenge, and we are glad to receive lots of positive feedback and attention on this challenge. In the next challenge, we plan to add a track for the more challenging and realistic semantic audiovisual navigation task. In addition, we plan to make it easier for participants to participate by enabling the simulator to render on the fly. Also, we wish to test the winning team's method on a real robot in the future. Next is the presentation from the winning team. Thank you.
Hey everyone, it's Abdurrahman Yunus, a master student at the University of Freiburg. I'm going to present today our approach that won the SoundSpace challenge. This is a joint work with Daniel Hunakam, Tim Virchohold, and Abhinav Balada. We call our approach mimicking real-world scenarios for better audio-visual navigation. In embodied audio-visual navigation, the agent's goal is to navigate towards sound source in unmapped complex realistic 3D environments, using only audio and RGB depth images. The SoundSpace challenge addresses the problem of navigation to previously unheard sound in unseen environment, as existing approach suffer to generalize well to unheard sounds. We believe that mimicking more complex real-world scenarios in the training process can help the agent to learn the task more effectively. We can mimic a scenario like a crying baby at the same location where the alarm went off by adding a second sound emitting source at a goal location. Another more common scenario like a ringing phone while there are people talking at a different location can be integrated into training by adding a distractor sound at a different location. A third scenario where there is a noise in the audio sensors can be mimicked by applying future-wise augmentation on the binaural spectrogram. We have also added an additional auxiliary task inspired by self-supervised learning, in which the agent is expected to learn how to reconstruct the current step spectrogram. This task induces the network to learn a better latent space. In order to integrate effectively the previous mentioned complex scenarios in training to provide the agent with a highly diverse training experience, we have implemented a training pipeline which does the randomization in two levels, episode level and the step level. Starting with episode level randomization, the pipeline would decide whether to include a second sound at the goal location or not, and if it chooses to include it, then it will need to randomly select that different audio from the available training sounds. It has also to decide whether to include a distractor sound in the current episode or not. In the step level randomization, the pipeline starts to take random decisions like whether to include a distractor sound in the current step or not, and if yes, the pipeline needs to randomly select a different audio to act as a distractor sound. Then, it has to randomly choose where to locate it inside the environment. The pipeline has also to decide if it's going to apply a future-wise augmentation or not, and if yes, it has to randomly select which type of augmentation it will use. It can select whether to use time masking, frequency masking, or a combination of both. Our second main contribution is introducing reconstruction of the current step spectrogram as an auxiliary task for the agent to learn, as it provides the agent with a dense self-supervised learning signal by improving the encoded latent space to make sure that it preserves the crucial spectrogram features. We have used the mean square error to calculate the auxiliary loss. Here we show how we have integrated our approach with the current state-of-the-art model audio-visual navigation waypoints by Shen et al. As you can see, our randomization pipeline passes the current binaural spectrogram to the audio map and the audio encoder, which we have added an audio decoder after it to reconstruct the current spectrogram. Finally, we compare it with the original one in order to calculate the auxiliary loss. We show our results on unheard sound datasets, first on the challenge dataset, second on the SoundSpace dataset. Our approach has outperformed the state-of-the-art and increased the success rate by 18% on the challenge dataset and 21% on the SoundSpace dataset. We have achieved also a better SPL by 13% on the challenge dataset and 11% on the SoundSpace dataset. To conclude, more complex navigation tasks with strong perturbations and additional audio signals improve the performance on unheard sounds at test time. Reconstructing the current spectrogram is a useful auxiliary task for audio-visual navigation. Our approach has outperformed the state-of-the-art by a large margin in all metrics. These are the references that we have used in our work. Finally, I would like to thank you for your attention, and I would like also to thank the SoundSpace organizing team for providing this challenge, and especially Shangshan Chen for his unstoppable support throughout the challenge process.